Welcome to Math 1400, prerequisite number 3, the coordinate plane. The coordinate plane is going to be two number lines connected at a single point called the origin. One is going to be a vertical number line, one will be a horizontal number line. The horizontal number line is called the x-axis. The vertical number line is going to be called the y-axis. Where they meet, I said, is called the origin, and this is the 0 point on the x-axis. Numbers to the right are the positive counting numbers, 1, 2, 3, and so on. To the left is the negative numbers. The y-axis, going up, is the positive numbers, and going down is the negative numbers. We can find our way around the coordinate plane by using what's called coordinates or ordered pairs. A coordinate is going to be two numbers separated by a comma. We're going to have the number on the left, which is going to be our x number. It's going to tell us where to go on the x number line. We have our y number, which is going to be our number going up and down on the y-axis. Again, together these numbers are called an ordered pair, and when we plot it on the coordinate plane, it's called a coordinate. Suppose I have the numbers 1, 2. 1, 2 is the ordered pair. The point we would put on here would be 1 on the x-axis. So we go on the x-axis to 1. We'd go to 2 on the y-axis, so we'd go to 2 on the y-axis, and where the 2 would meet would be our point, which would be 1, 2. We do this for any numbers that we have, or any points that we have on the coordinate plane. Suppose I wanted to plot the points 3, 4, 0, 0, 3, 4, 0, 0, 3, 0, and negative 2, 3. 3, 0, and negative 2, 3. If these were the points that we were looking at, first one, we have what? 3 on the x coordinate and 4 on the y coordinate. So 3 and 4. So we go to 3 for the x, 4 for the y. They would meet up here. This would be my ordered pair, 3, 4. If I wanted to do 0, 0, well, where they meet at the origin would be 0, 0. So it would literally be a point on the origin, or at the origin. 3, 0 would be 3 on the x-axis and 0 on the y-axis, so it would not move from the axis, it would stay right there. And negative 2, 3 would be negative 2 on the x-axis, 3 on the y-axis. It would meet over here. This would be negative 2, 3. Also, the coordinate plane with the axes separates this whole plane. Plane is just a flat surface. Separates the whole plane into what we call quadrants, quad being 4. So we would have this on the upper left hand as quadrant number 1. We put it as a capital Q, and it's a Roman numeral 1. To the left on the top would be quadrant number 2. The left on the bottom would be quadrant number 3, going around in a counterclockwise direction. And then we'd have finally quadrant number 4. So this would be the quadrants on the coordinate plane. Again, the coordinate plane is nothing more than two number lines, an X and a Y number line. So once we've done that, we can now look at maybe joining up points and finding the length from one point to another. In order to find the length between 2 points, we're going to use something called the distance formula. We're going to use the distance formula. So the distance formula, written with a little d, is going to be a version of the Pythagorean theorem. Pythagorean theorem was finding the lengths of right triangles. So if we were trying to find the distance here, we would draw a right triangle out of it, and we would do a squared plus b
This
squared.
is an roll call for students that need to take pictures. If you need to take a picture and did not get a chance to take a picture, please report to the auditorium at this time.
We would do the a squared plus the b squared equals the c squared. Hence, this distance formula I'm about to put on the board. It's going to take into account with the squareds as doing the square root of the difference of the x's, which is x2 minus x1, difference being subtract, squared, plus the difference of the y squared, y2 minus y1 squared. We have 2 and 1 because it's going to be two distinct points that we're trying to find the distance between, okay? So the next example says find the distance between the points -2, 1, so -2, 1, and this is my and symbol, an upside down V, and 3, 4. So they don't have to be plotted, but we could plot them. So we're trying to find a distance between -2, 1 and 3, 4. So if I did want to plot them, -2, 1 would be -2, 1. And 3, 4 would be 2, 3, 4, up here. 3, 4. So we're literally trying to find the distance from one point to the next. Again, it doesn't have to be plotted, it could just be the points. We plug them in. So we're gonna let x1, y1 be the -2, 1. Again, we just designated that as the first point. We're gonna let x2, y2 be 3, 4. So now we know what numbers to put into the formula. So we have our distance, and the distance is going to be the square root of x2, which is 3, minus x1, so minus -2 is +2 squared, plus y2, which is 4, minus y1, so -1 squared. Our distance is going to be the square root of 5 squared plus 3 squared. So that's going to be what? 25 plus 9, which is going to be the square root of 34. So our distance from here to here is the square root of 34. Now, we don't have to leave it as a radical being a square root. We could change it to a decimal, which comes up to be approximately 5.83. Again, your calculator will do that for you once you press in the buttons. If they ask for the actual value, it's the square root of 34. If they ask for a decimal approximation, it's 5.38. Okay, suppose they want us to find the distance between two more points. Suppose we have, the first point is -1, -2. -1, -2. And the second point is going to be 3, 1. Again, I could plot it up here, or we could just designate this to be the first point and this to be the second point. If we just designate, that's going to be what? The square root of x2, which is 3, minus x1, so minus a -1 is +1 squared, plus y2, which is going to be 1, minus y1, which is going to be +2 squared, because again, minus a negative. That's going to give me what? The square root of 4 squared plus 3 squared, which is going to be the square root of 16 plus 9, which is the square root of 25. So our d in this case, the distance is the square root of 25. But unlike the first one where the square root of 34 was a 5.38, it was an approximation, so you could give it either way, depending on which way it asked. This one here, the square root of 25, is a perfect square, so the answer is 5. We would not leave it as a radical, the answer would be 5. And that is the distance formula. Now, we also could find something else out. We could find something called the midpoint. So this is the distance formula. Midpoint, if I'm looking back at this one, would be the middle point. So we now want to find a way to find the midpoint once we have the total length. So let me erase some of this so we have more room. Okay, and now they said that we want the midpoint formula. So the midpoint formula, that's my abbreviation for midpoint, MIDPT. The midpoint formula is going to be the average. It's going to be the average of the x's to bring it to here, and the average of the y's to bring it to the middle. So the average is going to be x1 plus x2 over 2, the average of the two x's, and it's going to be an ordered pair. It's going to be an ordered pair, so it's going to be y1 plus y2 over 2. So if they want us to find the midpoint of the segment joining the 2 points -5, -3, and the second point, which is 9, 3, we would plug it into the formula. Again, we would let this be 1, let this be 2. Again, I'm just determining that. You can go whatever way you want. So I'll put this as x1, y1, and I'll have this as my second point, x2, y2. So once I put it in the formula here, I'd have what? -5 plus 9 over 2, and -3 plus 3 over 2. So that my midpoint would be 4 over 2, 0 over 2, which would be what? 2, 0. So my midpoint for these 2 points would be 2, 0. And that is what we have for the distance formula and for the midpoint formula. Now, finally, they're going to ask us to find what quadrant a point is in. To find what quadrant a point is in. And we kind of talked about quadrants being quadrant 1, 2, 3, and 4, going in the counterclockwise direction. But to actually know what quadrant we're in, we have some facts about the quadrants. We have some facts about the quadrants. So in quadrant 1, we said that the top right-hand corner was quadrant 1. I know that this is the positive portion of the x number line, or the x-axis, and it's the positive portion of the y-axis. So my coordinate in the first quadrant, x is going to be positive, and y is going to be positive, because it's the positive side of the x number line and the positive side of the y number line. In quadrant 2, however, the x's are negative. It's the negative side. So the x would be negative, but my y would still be positive. So any coordinate that's in this quadrant would have a negative x value and a positive y value. In the third quadrant, the x's are negative and the y's are negative. And in the fourth quadrant, the x is positive and the y is negative. So the next question, or the next example says, determine the quadrant in which the coordinate is located. And they give us that, we'll put this as A, x is greater than 0 and y is less than 0. So they want us to know what quadrant we're in if x is greater than 0 and y is less than 0. Well, having it up here, I can kind of look and match it up, which goes with it. But what I like to do is I like to draw coordinate plane and check off where it's true. The x's are positive where? The x's are positive where the x number line is positive. So the x is positive here in this quadrant, and the x is positive here in this quadrant, or in quadrant 1 and quadrant 4. The y, on the other hand, is negative, and the y's are negative where? Well, it's the y number line. The y's are negative on the bottom. So the y is negative here in the 3rd quadrant, and the y is negative here in the 4th quadrant. Where the two meet up is the quadrant where the point is at. And this would be quadrant 4. Again, all I'm doing is looking through this. X is positive, y is negative, quadrant 4. But I'm doing it in this style where I'm listing where my x's are positive, could be the 1st one or the 4th one, and listing where my y is negative. It could be the 3rd one, it could be the 4th one. They both meet up in quadrant 4. Suppose I'm looking for where x is positive, or x is greater than 0, sorry. Where it's greater than 0 means it's positive. Where it's less than 0 means it's negative. And I'm looking for my y is also greater than 0. So in this case, my x is positive and my y is positive. So if I did this, my x is positive in the 1st and the 4th, right side. And my y is positive, what? In my 2nd and my 1st. So therefore, they both meet up here. That would be quadrant 1. And then for the last one, they might throw us in a little something sneaky. Like they might say x equals negative 1. X equals negative 1. And y is greater than 0. So if x is equal to negative 1, we know where that's at. We'll have our coordinate plane. X is equal to negative 1 here. So that means my x is going to be to the left-hand side. So it's got to be either here or here. So it's either the 2nd or the 3rd quadrant. But at the same time, y is greater than 0, so my y is greater than 0 at the top, so it would be either the 2nd or the 1st. They both meet up in the 2nd, so quadrant number 2 would be the quadrant that the ordered pair lies. So again, we have the coordinate plane, the distance formula to find the distance between 2 points, the midpoint formula to find what the middle point would be, which is the average, and what quadrant does the coordinate lie. That is P3, which is for the Math 1400 for Nunez Community College. I'll catch you at the next one.